Hello and welcome to the System 8 Multiple Instrument Station video tutorial. The Multiple Instrument Station, or MIS, is a module designed for the acquisition of all standard electrical measurements as well as a generation of test signals. Let's start by having a look at a known instrument, the digital storage oscilloscope. The MIS oscilloscope offers all the acquisition modes to capture even the most elusive signals. The channel sensitivity can be set independently on each channel. A channel offset is also available to isolate waveforms, whilst channels can be coupled to ground, DC or AC. Each channel can be disabled for better visibility. The comparison feature automatically creates a mask of the signal. This mask can then be compared to any other signal. The comparison tolerance can be set here, as well as the pass or fail threshold. The mask can be removed or disabled completely. The calculator is a unique feature allowing the live processing and storage of data. Its functionality is based around a very easy and simple to write program. In this case, the program simply displays the frequency of the signal being measured. The result is shown in the main window. A status bar gives a simple pass or fail result should the measurement be within the tolerance of the target. This is simply shown with a red or green bar. Please note that data logging will be exported as CSV file. Back in the oscilloscope, signals can be triggered on channel 1 or 2, an external signal or the internal function generator. The rest of the trigger section includes trigger level, trigger slope, trigger delay and trigger coupling. Finally, the time base, including extended resolution sampling, can be set here. Standard signal measurements can be done very easily with the MIS oscilloscope using the Measure button. A total of 28 measurements can be acquired with a single click. Multiple measurements are of course available. This completes the MIS Digital Storage Oscilloscope overview. The next instrument on the MIS module is a digital floating multimeter. Channel 1 is dedicated to the measurement of DC and AC voltages. Standard measurement statistics are shown below and can be reset here. Channel 2 is for the measurements of voltages DC and AC, currents DC and AC, and resistance. Measurement statistics are also shown here. Once again, the calculator can be used to process and log data. In this example, the measurement on channel 1 will be added to the measurement on channel 2. The result is shown in the main window. Once again, the status bar can be used for a quick pass or fail comparison test. Instabilities in the signals can also be viewed using the status bar. This completes the MIS digital multimeter overview. Next in line, the MIS function generator. For the purpose of this tutorial, the output of the function generator will be linked to the input of the oscilloscope. This will make changes to the function generator settings easier to see. The function generator can output AC signals with a selectable frequency. The range goes from 0.1 Hz to 10 MHz. The duty cycle of the signal can also be modified. A phase lock option allows for a stable output frequency. The waveform of the signal can be changed from sine wave, square wave, triangular wave, or independent pulses. The amplitude of the output signal can be changed to suit various applications. A DC offset can also be added. Preset buttons make these settings easier to select. The graphical viewer gives a preview of the output signal. The modulation section is used to add AM, FM and PWM modulation to the signal. The modulation ratio can be adjusted as can be seen here. The sweep function is a way of changing the frequency of the output signals automatically, from a start point to an end point. This transition can be done with a selectable number of steps with a particular duration per step. A linear transition or logarithmic transition can be used. You may observe the effects here. This concludes the MIS function generator overview. The next instrument to be described is the frequency and event counter. The frequency counter allows for the accurate and precise measurements of signal frequencies. Channel 1 is used for high frequency signals of up to 150 MHz. Results can be shown as frequencies, periods or RPMs. Channel 2 is used for lower frequency signals. Measurement statistics are once again available and can be reset. As is the case with other instruments, the calculator can be used to process live data and store data in a CSV file. The sum of both frequencies is processed here. The frequency counter can also be used in event mode, whereby occurrences on a signal, such as pulses, can be counted automatically. The trigger mode, prompting the system to start and stop counting, can be selected here for various applications. This completes the frequency and event counter overview. The MIS also offers a set of programmable channels known as the Universal I/O. A set of 4 analog and also 4 digital channels are available. Each analog channel can be set as an input to measure a voltage or current, or as an output to generate a programmable voltage or current. And the digital channels can measure or output logic levels. Finally, the MIS module also offers a set power supply for low power applications. The outputs are set to +5 volts, +9 volts and -9 volts with a power on switch. One of the unique advantages of the MIS instrument is that their design can be customized. The appearance of each instrument can be changed by entering the Instrument Design Manager window. Instrument windows can be resized and the position of sections can be changed. In this example, the oscilloscope is changed to include an RMS voltage measurement on both channels using the calculator. All the buttons that are not used can simply be hidden. The new instrument can be given a different name. The same applies to sections of the instrument. In order to be able to reuse the new instrument, the design must be saved. This section shows how the calculator can be set up to display the RMS voltage in the results window. Here is the formula used. Measurements can now be acquired with our newly designed instrument. As can be seen here, the newly designed instrument is not part of the Instruments drop-down menu. For this option, use the Instrument Menu Manager. This option allows you to add, remove or change instruments in a drop-down menu. The newly designed instrument is now part of the drop-down menu, which makes for an easier access. As an example, please take a look at another customized instrument, the ABI's test station. You will notice that instruments previously available in separate windows are all available on the same instrument window here. In this case, the power supply, the function generator, the multimeter and the oscilloscope are all available on the same window. You will also notice the presence of pictures and text which can be added at will. Whilst all of the MIS instruments can be used at the same time in separate windows, it may be more convenient to design a customized view. You may also want to customize your instruments with your own company logo. This completes the MIS video tutorial. For more information, please visit our website at abielectronics.co.uk.